In this course you will learn all about kernel development. We start off small by learning Intel's real mode, where we develop an actual bootloader that can boot from real hardware. We actually boot it on our real computers and we see Hello World on the screen. And there we go, Hello World. This program is self-efficient. It requires no operating system. It is bootable code. Your journey starts here. Throughout real mode we also load sectors from our hard disk into memory. Now, real mode is a compatibility mode by Intel that allows Intel processors to run as they ran maybe 20 or 30 years ago. Real mode is a legacy mode by Intel. It is fairly limited, but learning it is essential. After we work with Intel's legacy mode called real mode, we move to what's known as protected mode, which is what all 32-bit operating systems use. You are taught all about protected mode in this course. You learn all about virtual memory, memory virtualization, mapping virtual addresses to physical addresses. Our processors all share the same addresses. How is this even possible? Well, you will find out in this course. We can have multiple processors running and they all share the same memory addresses. This is amazing. It's called paging. And this is all taught to you. And by using paging, we can prevent processes from seeing certain parts of memory. It's a great security feature, and it allows us to compile all user programs at the same address. You're going to learn all about this in this course. Your kernel will be capable of handling the entire system memory. It'll be able to allocate memory to different processes. It'll be able to restrict memory access from certain processes. This course shows you how to create processes for your operating system and load them into memory and run them. And we can have multitasking. In this course you're taught how to make a multitasking kernel. We can have multiple processes running at the exact same time. Our processes can also be of the ELF file format. Okay? In this course we support two types of loading. We can load binary files and we can load ELF files. Now all Linux programs are ELF files. We're implementing an ELF loader that can actually load ELF files into memory. Now I'm not saying you'll be able to run Linux programs. What I am saying is you will be able to load ELF files, which is fantastic because ELF files have headers. They have information describing the process and how it should be laid in memory. This is much more efficient than loading just binary files. So this course takes you a step further by creating an actual ELF loader. You're also taught how to handle malicious programs. Not all programs are nice. What if someone writes a program that tries to modify your kernel? Well, in our kernel, the kernel will know that you've done that and it will kill the process. This is achieved by using paging and setting up certain security rules on the different memory that the process can access. If it violates those rules, an interrupt exception is called and our kernel will say no, no, no. It'll kill the process and unload it from memory. You're going to learn all of that and how to do that in this course. You're also going to learn how to handle program crashes. Sometimes programs do things by accident that they shouldn't, right? Now, we need to handle that. If we don't handle that, the process stays loaded in memory. Now, you're taught how to unload the program when it crashes and how to detect when a program's crashed. By the end of this course, you can expect to have a fully working 32-bit kernel and operating system with an interactive shell. Okay, think of command prompt. You can type into command prompt. That's our interactive shell, something like that. Your operating system and kernel will also be a multitasking operating system and kernel, as I've already said. So we'll have multiple processes running at the same time. You're going to learn how to do that in this course. And by the end of this course, you will understand kernel and operating system development very well. And you'll be able to take what you've learned to improve your kernel, adding new features, and who knows, maybe it'll be the next Linux. Enroll in this course today.